Here's an example of how you find the extreme values of a function on an open interval. In essence, we've been asked to find the extreme values of f of x equals x over x squared plus 16, and they gave us no interval, so we're going to assume that's from minus infinity to plus infinity. So as normal, the first thing we need to do is differentiate this function and find any critical values. So f of x was the function x over x squared plus 16. And so f prime of x is going to be the derivative of the top times the bottom, which is 1 times x squared plus 16, minus the derivative of the bottom, which is 2x times the top, so that's 2x times x, and then divided by the bottom square, which is x squared plus 16 all squared. If we simplify that a bit, we get f prime of x is equal to, well, I'm going to have an x squared minus 2x squared on the top, so that's going to be minus x squared, and so I'm going to end up with 16 is equals to minus x squared all over x squared plus 16 squared. And so I see that this derivative will be equal to 0 when 16 minus x squared is equal to 0, or when x is equal to plus or minus 4. And the derivative is never undefined because x squared plus 16, this portion right here, will never be 0. And so I don't have to look there for a critical value. And then just as a double check, I want to make sure that these values I've got here, this x equals plus or minus 4, of course these have to be in the domain of my function, and they are. There's no problem plugging plus or minus 4 into that function. So I'm in good shape. I found my critical values. And so I know that the extrema have to occur at the critical values or at the endpoints. In this case, my endpoints are minus infinity and plus infinity, which are not attainable, but I can take limits at those endpoints to see what's happening as a function approaches plus and minus infinity and add those in. So I'm going to find f of minus 4, which I plug minus 4 into the function. I'm going to get minus 4 over 2 times 16, because it'll be 16 plus 16. And so this will be equal to minus 1 over 2 times 8, or minus 1/16. So when I plug minus 4 into the function, oh, I'm sorry, I made an error there. I think that, make sure I've got this right. Well, minus 4 goes into 16 minus 4 times, so that's going to be, let's get this right. If we're careful here, this will be minus 1 over 2 times 4, or minus an eighth. All right, and so if I plug in 4, it'll be very similar. It's just going to change the sign, so that's going to be 4 over 2 times 16, and that will be minus 1. I'm sorry, that's plus 1 now. So 1 over 2 times 4, which is 1/8. All right, so f of minus 4 is minus 1/8. F of 4 is 1/8. And now I need to check the limits of the function, and just so I can remember here, that function was f of x is equal to x over x squared plus 16. So I want to know what's happening to the function as it approaches minus infinity and what's happening as it's approaching plus infinity, because at those endpoints I may have extrema as well. So the limit as x goes to infinity of f of x. If we look at our function, it's a rational expression, and so when taking the limit of that, I just have to consider the highest power of the numerator and denominator, which is x over x squared. Since the denominator is larger than the numerator, then this limit will be 0. And then I have the limit as x goes to minus infinity, in which I can apply the same technique, and so that as well will be 0. So the extrema for this function are going to be at minus 1 over 8, 1/8, 0, or 0 twice, right? So the largest value occurs when we plug in 4. Let's make some space here. So f of 4 then equal to 1/8 is the absolute max, because that's the largest value that can be attained. And the smallest value out of 1/8 minus 1/8 and 0 would be minus 1/8. So f of minus 4 equal to minus 1/8 is the absolute min. And in this problem, what's happening at the endpoints is not an extrema at all. So the maximum, the absolute maximum, occurs at 4 and is 1/8. And the absolute minimum occurs at minus 4 and is minus 1/8.